Today is Thursday, January the 6th. We're going to do the warm-up. I'm going to go over the notes from yesterday on residuals. I'm going to give you just a little bit of time to complete the independent assignment from yesterday on residuals. And then you're going to do the investigation on residuals. The investigation is a group assignment. Sorry. I don't know what I was thinking just then. The homework is the same. Make sure that you finish the study guide. The questions that are on the study guide are very similar to what you're going to see on your test. Tomorrow you're going to submit your work. I'm going to give you more time to complete the investigation. So the investigation is not due tomorrow because you won't finish it today, okay? You won't have time to finish it today. So we'll finish that up on Monday, okay? But you'll submit everything else. Okay, so remember the submitted, if you haven't already done so, it's the line of best fit worksheet before the break, and it's on week 8 page. The warm-up, the study guide, and the independent practice assignment, okay? The independent practice assignment. Those are the things that you're submitting, and then you'll work on the test. Please watch the video. You're not going to be prepared if you don't watch the video. Questions, comments, or concerns? Okay. All right, let's look at the warm-up, please. Look at the warm-up, please. All right, today I want you to just do 1 and 2, and we'll cross out number 3 so we can have time to get some stuff done. Okay? I'm going to pause for the calls to give you a chance to work it out. So we're just doing 1 and 2. All right, so we started residuals yesterday. Residuals are how far your actual Y values in a scatter plot are away from the predicted values that are in a scatter plot, okay? So the formula for residual is your actual Y values minus your predicted Y values, okay? The first thing that you do to find your residuals is to find the line of best fit. If the line of best fit is not given, then you can find the line of best fit by typing in all of your points in the calculator here and do a linear regress. Don't forget, linear regress is stat, calc, and down to lean reg. Yes. It's calculator active, yes. Scatter plots is calculator active. Okay. So most of all your scatter plot questions are using the calculator, except for if they already give you the line of best fit. Sometimes they'll give you a line of best fit and they want you to substitute the number to figure out the answer. You don't need the calculator to do that. And if it is a question, is what type of correlation is this, positive? You don't need a calculator for those things. But everything else, you'll get a calculator for. Okay? That's a good question. All right. So your formula for residual, again, is your actual Y minus your predicted Y. That's your formula for residual. The first thing you do is find the line of best fit. If the line of best fit is not given, then you do the linear regress in the calculator. Okay? Then all of your Y values, your points that are on the line of best fit, the Y values on the line of best fit are going to be your predicted values. Okay? So you need the line of best fit to figure out what the predicted Y's are. Your actual is already given. Those Y values are given. Those are the actual points. Whatever the Y value is for this point, the Y value for this point, so on and so forth. Residual. Your residual is always going to be It's always going to be actual minus predicted. So let's look at this. Let's look at this point right here. How far is this point away from the line? That's your residual. Is this residual going to be a positive number or a negative number? Negative. Why? Because it's below the line. Okay. What about this residual? What number is that residual going to? It's 0 because it's what? On the line. What about the residual for this point right here? Is it positive or negative? It's positive. How do you know it's positive? Because the point is above the line. What about the residual for this point right here? Negative. Why? Because it's below the line. What about the residual for this point right here? Positive. Why? It's above the line. What about the residual for this point here? It's going to be a negative number. Why? It's below the line. And the last one, what about this one? Why? It's above the line. So sometimes you'll see a plot that looks like this. All this is doing is illustrating to you what the residual is or where the residual is. Okay? It's this distance from here to here. It's this distance or length. This distance or length. This distance or length. So when you see a graph that looks like this, it's just illustrating to you where the residuals are. Any questions about that? Okay, that's the one part that I didn't show you from yesterday. All right, the sheet. I think I gave you the sheet yesterday. If I didn't, then I'll give you one today. Probably not because I got so many. Did I give you this one? Yeah. Oh, you do have the sheet. Okay, this sheet is for grade. So this sheet, you need to make sure you do it first because this is what you're going to submit for grade to make sure that you understand what you are doing. Have you started the sheet yet? No. Okay, so let's take this sheet out and let's do this sheet now. This is for a grade. Okay, anybody not get the sheet? Yeah, that's right. I don't think we started it yesterday. I don't think so. Yeah, I don't think we started it. Oh yeah, she did start it. She started it already. So that's fine. All right. Okay, yeah, you need one? Yes. No, this was independent. No, just put it. It took that one in your notebook. That was just practice. Now the sheet that I just gave you, that's what you're doing in your group. This one's the investigation. You're doing that in your group. Yesterday I was gonna have y'all do that in your group, but then I got on my nerves. So then I changed my mind. Whatever. You can't blame that all on Sammy. All right, so this right here, I need you to submit this for a grade. So guys, you need to focus on getting this done. If you're already finished, you go ahead and start reading the investigation. That's just guided practice. Don't worry about that. Paste that in your notebook. Did I tell you what page to put that on? Yes, that's right. It's the same. No, it's not. It's a different sheet. Yes. Oh yeah, that's fine. Too busy. All right. Go through this real quickly with you. Okay. Don't forget, the line of best fit is already given. It's right here. Okay. So with your line of best fit, you type it in under y equals 0.5x, and your predicted values come from the table. Look, I want to remember yesterday we just typed these in. So in order to be able to do that, you go to second window and put it on X. Okay. So that way, when you go to the table, second graph, you can just type the numbers in. So I can type in 5, 10, 15, 20, 25, 30. Okay. And then those are my predicted values here. Okay. Mm-hmm.
How do you find out like what to put in like the Y1 spot?
Yeah.
Why one spot?
It's just Y. It's the observed value. See?
You talking about the Y?
What do you mean?
Never mind.
You got it?
Yeah.
Okay.
Just talk about that.
Don't do that, little boy.
See that.
Yes. I can't hear you. I'm sorry.
That what she had.
Very different numbers. The same one.
Okay, guys, look. I'm going to do it one more time. Please pay attention to what I'm doing. Okay? If I'm moving too fast for you, then you need to say, Miss Reyes, can you slow it down? But you're not saying that. You're letting me move on and you don't get it. That's bothersome. You got to say, I don't understand it. Don't wait till something is great and then be like, oh my God, I'm lost, and you panicking. You need to say when you don't understand something. You need to tell me. All right, so I'm going to start again. Second plus 7, 1, 2. Please listen so you'll know. Okay, the first thing, in order to figure out what your residual is, you're going to use your line of best fit. To go to find your predicted values, you type in your line of best fit under y equals. I think everybody got that part. 0.5x y equals. Listen. All right, so now after you do that, you want to view your function table. So just press second graph. Look, if I go here, I've got to keep moving my arrow down to get to my x values. Okay, so I have to find 5. You see where 5 is? What's the predicted value for y? 2.5. So that's what I put here. 2.5. Okay. What's the predicted value for 10? So I go down to 10. My predicted value is 5. Okay. What's my predicted value for 15? I go down and look at 15. 7.5. If I don't want to keep going up and down the list, then what I could do is press second window, and instead of having it auto for X, which is your independent, I can change my auto to X only for independent. Please don't do it for both, because you want the calculator to give you the answer. Okay? So now, when I do this second, I can type in my X value. So I type in 20, and it gives me 10 for my predicted. I type in 25, and it gives me what? 12.5. I type in 30, and what does that give me? So on and so forth. Any questions? Yes. Okay. Did y'all not do the example that we did yesterday? It's the same thing. I'll do it again. You gotta listen. If you're not sure, say you're not sure then, because we're doing the same problem over again. Okay? This is the exact same problem. All right, here we go. So this is your predicted. Let's do residual now. Does anybody remember what the formula is for residual? The actual or observed, same thing. Actual minus predicted. This is your actual or your observed. It's the same thing. So let's subtract 3 minus 2.5. What's 3 minus 2.5? 0.5. It's a positive because this point is above the line of best fit. What about this one? Is this going to be a positive number or a negative? Negative, because this point is below this number. Okay, it's below the line of best fit. It's going to be a negative what? 1. Okay, 9 minus 7.5. 1.5. 7 minus 10. Negative 3. 13 minus 12.5. 0.5. 15 minus 15. 0. Same one we did yesterday, okay, y'all? Literally, same one. All right, so now look. We graph. Pay attention to how we're graphing it, okay? The y's, this is going to be our y because we're graphing the residual values. So we're going to put the residual values along the y-axis, okay? Because that's what it's asking for. It says construct the residual plot. So we put residual along the y. Okay, these are your residuals. You put that along the y. Your x values are here. That goes along the x-axis. This is your y. This is your x. Okay? So let's look. Let's see what scale can we go up by on the x. It's not a lot of space, so we might need to go up by 5s. 5, 10, 15, 20, 25. Let's just do it. Because we won't be able to really do anything else. Go up by 10, 10, 20, 30. That's going to be real close. So let's just do 5, and we'll add another little line over here for 30. All right. So this is going up by 5s. 5, 10, 15, 20, 25, 30 is over here. Okay? And this is going up by, let's see, our lowest number is negative 3. So we're going to have to go up by 1s. So this is going to be 1, 2, I can put it here, 0, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay? Excuse me. Sorry, y'all. So now, let's graph this first one. This is what we're graphing. 5 is our x. Our residual is 0.5. So we go over 5 and up to 0.5, which is right here in the middle. Are you okay with that? You sure? The next one is 10 and negative 1. So go over to 10. This is 5. This is 10 and down 1. That makes sense? 15 and 1.5. 5, 10. This is 15. 1.5 is up 1.5 is right here. 20, this is 20, and negative 3 is down 3. 25 is right here, and 0.5 is right here. 30 is right here, and 0 is right on the line. Okay? So this is how you graph that. Any questions? Does this suggest that it's a linear relationship? It does. We talked about this yesterday. The reason why it does, you have about the same number of points on the top of the line as below the line. And it's almost symmetrical. They're almost right there together. They're almost the same distance from each other on top as below. So you know that line is in the center. If these points are kind of symmetrical, then we know that's a good line of best fit. So this is linear. The closer they get to this line, the closer that they get to this line means it's close to being a straight, perfectly straight line, okay? So this is a yes. The points are almost symmetrical. If you have more points on the top than you have on the bottom, that might not be a good line of best fit because it's not in the center. If you have more points on the bottom than above, again, it's not in the center of the data. If it's not symmetrical, it's way up here and then way below here, then it might not be a good line of best fit because it needs to also be balanced. It needs to be symmetrical. You were first. What's up, baby? Yes. What's your question?
I know how to graph it, but so if this is just a linear relationship, they're both of it is even, like on the top one.
Yes, on top and bottom. Mm-hmm. Anybody else? Any other questions on this? You got 2 more to do on your own. And then you're going to submit this as a grade. I don't want no more talking. I'm going to give you a couple minutes. I want you to do on your own. On your own. That's the only way I know that you understand what we're doing. This is an independent assignment. You're going to submit this online. Submit it tomorrow. Any questions? That's just guided practice. Don't worry about that sheet. Just paste it in your notebook. Huh?
I don't got
Yeah.
that. I don't got that one.
Okay. Here you go, babe. Anybody else need that sheet? What's up, man? This is just guided practice. Just put it in your notebook. Oh, okay. Yeah. I was just stop with it. Yeah. Why? Are you okay?